in this video, we talk about the length of a vector. We know that a vector is just a direct line segment. So when I write this, like double bars, similar to the absolute value, but I use double bars. So this would be the notation for the length of the vector u. Okay? So give you an example. Suppose I have a vector u being 2, 1. I used 2, 1 already. Let's do 3, 5. And I want given vector u. And I want you to find the length of u. Okay. So let's plot out the vector u. By seeing it only has 2 components in the notation, I know it's a vector in R2. Okay? 3 units in x direction. 1, 2, 3, 4, 5. 5 units in the y direction. So it's a vector going from 0, 0 to the point 3,5. Now, the task I have is to find the length of this line segment. So what do we find this length? We know that by the segment theorem, the length of this would be square root of the length in the y direction plus the square of the length in the y direction. So u would have lengths equal to the square root of the square of x direction plus the square of the y direction. So that is square root 9 plus 25, which is root 34. Okay? So in general, for a 2-dimensional vector, or vector in R2, I'm sorry, vector in R2, we have the length u given by the formula square root of u1 squared plus u2 squared. Okay. And if I have a vector in R3, let's call it a different name, v given by v1, v2, v3. Now this is a vector in the 3-dimensional space. It has the length given by the formula square root of v1 squared plus v2 squared plus v3 squared. Okay? So question for you. Find the length of the vector v given by 2, 1, 3. So this is a vector that you plotted. I want you to find the length of this vector. So this is my answer. The length of this vector v is root 15. Do you have the same answer as I have? Okay, so now using these formulas, you can easily find the length of a vector in R2 or in R3.